Hey everyone, as you know, we have started studying equivalent fractions in math class. So this little video tutorial will explain how to identify and create equivalent fractions. So when we're done with this lesson, you should be able to identify if a fraction is equivalent to another one, and you should be able to come up with examples of equivalent fractions on your own. So let's look at this problem real fast. Andy, Lee, and Val each ate half of a pizza. The pizzas were the same size, but Andy ate one piece, Lee ate 3 slices, and Val ate 4 slices. How is this possible? And by the way, piece is the same as a slice. They're synonyms for each other. So Andy ate 1 slice, Lee ate 3 slices, and Val ate 4, and yet they each ate half of the pizza. So how is that possible? We'll come back to this problem later after studying equivalent fractions more. So let's review what we know about fractions. What is this number on the top called? Do you remember? I'll give you a clue. Remember, I say north. It is the numerator, and I always say numerator north because usually, north is the upper part on a map. And when we're talking about the numerator, you have to remember we're talking about the parts that we care about. The numerator is the parts we care about. And now, what is this one again? This one is the denominator. Think denominator down, numerator north. And the denominator is your total parts of your whole. When we're talking about numerators and denominators, you see them all the time. For example, let's say we're talking about a spelling test. Unfortunately, this kid didn't do very well in his spelling test. His fraction that he got correct is only 4 out of 10. There were 10 total questions, and if we're talking about how many he got correct, he only got 4 correct. 1, 2, 3, 4. Now, if we were talking about a different part, we could say he got 6 out of 10 incorrect or wrong. So it all depends on what you're asking about. Look at this kid. This kid studied for their spelling test. They got 10 out of 10 correct. 10 questions asked, and all 10 were answered correctly. You see fractions all the time. For example, in a baseball game, maybe this baseball player got 3 hits out of 4 times that he batted. So one time out of those 4 during the same game, he got out, whether he struck out or something happened to him. So 3 out of 4 times he got a hit. 1/4 of the time he did not get a hit. So we see fractions everywhere. Let's practice creating fractions. So creating equivalent fractions, Now remember, an equivalent fraction means they're the same size but cut into different size pieces. So let's say we have 2/4. Okay? This square is going to be 2/4. So remember, your numerator is what you're talking about. Your denominator is your total pieces. So our denominator is 4, which means we need to cut this rectangle into 4 equal pieces. So whenever you're doing this, just try to do it the best you can. Try and do it the most accurate you can to equal size pieces. Fractions are always equal pieces. So here is my 4ths, and I should shade in 2 out of 4 of them. Let me make this a little bigger. So 1/4 is shaded in red, and now 2/4 is shaded in red. let's create a fraction that's equivalent to that. So we have 2/4. We want to make a fraction that's equivalent. Equivalent means equal. So it's going to be the same size whole. We're just going to cut the pieces into different sizes. So I think I'll cut them once here. X. And once here. So now, ask yourself, what is your new denominator? It's the same size. Remember, this is the same size as this. You know that because I just copied it. But how many slices do we have now as our total? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 slices. And how many of those are shaded in red? 1, 2, 3, 4, 5, 6. So we have 6 out of 12 shaded in red, while here we have 2 out of 4 shaded in red. Notice the size of the rectangle is the same in both, but in the fourths, each fourth is bigger than a 12th. And that should make sense because when you have a whole and you cut it into more pieces, each piece is going to be smaller. Think about a pizza. Oh, actually, we'll come back to the pizza idea later. So 2/4 is equal to 6/12. And I taught you already, but let me review again. In addition to using pictures, I taught you the whatever you do the top, you do the bottom trick. I know these two are equivalent if I can multiply or divide the same number on the top and bottom and they get to the second fraction. For example, 2 times what, guys, equals 6? 2 times 3 equals 6. And whatever you do the top, you do the bottom. 4 times 3 equals 12. And that should make sense because why am I times it by 3? Because what you're saying is you cut each one of these into thirds. That's where you get your 3 from. Okay, let's try another one. This time, let's say we have thirds. So I want 3 equal pieces. So when you're cutting your fractions, try your best to make sure they're equal pieces. And let's say I have 2 of those thirds shaded in. So 2/3 are colored in green. You could also say 1/3 is colored in white. Let's find a fraction that's equivalent to this. So to make an equivalent fraction, all we're doing is we're taking the same size shape and cutting into different size pieces. How about I cut this going this way? So now, before we had thirds, how many total pieces do we have now? 1, 2, 3, 4, 5, 6. we have sixths. And how many are shaded in green? This time it's 1, 2, 3, 4. It's the exact same size shape, and the green pieces haven't changed. We just cut them into smaller pieces here. And we know that 2/3 is equal to 4/6 by using whatever we do the top, we do the bottom. 2 times 2 equals 4, and 3 times 2 equals 6. Using that trick, you could also show how fractions are not equivalent. For example, let's say this time we had 3 of these shaded in. So we're trying to find out if 2/3 is equivalent to 3/6. You should hopefully know they're not equivalent just because, look, this one has more green shaded in than this picture. But let's prove it using the whatever you do the top, you do the bottom trick. Well, I know 3 times 2 equals 6, but will 2 times 2 equal 3? No way. So these are not equivalent. All right. I also showed you, and I told you to take these home and use them, how fraction strips can help you figure out if a number is equivalent to another. For example, I want to know if if 2/8 is equivalent to 1/4. Let me try and check using my fraction strips. So that means 2/8 would be 1/8 plus another eighth, 2/8. Is that the same size as 1/4? Yes, it sure is. It looks like they're a little off, but it's just because of how I cut them. So yes, they are equivalent. Let me prove it again using the whatever you do the top, you do the bottom trick. 4 times 2 equals 8, and 1 times 2 equals 2. All right. Now, I know I passed out a sheet that you are supposed to be working on as you do this video lesson. So you'll see in the first one, it says, write the equivalent fractions. So these are pretty simple. You have to identify the fraction that's shown here and identify the fraction that's shown here, and you should see that they are the same size. So remember, our numerator is going to be the gray shaded in part. How many are shaded in? We have 1 shaded in. How many total pieces? 4. So 1/4. What is that equal to? Well, in this one, we have 2 shaded in. Out of how many total? 1, 2, 3, 4, 5, 6, 7, 8. Out of 2/8. Let me show you that that is true with the fraction strips. 1/4. Oh wait, I just did this one, I forgot. And 2/8. Let me also check again using whatever you do the top, you do the bottom. 4 times 2 equals 8. And 1 times 2 equals 2. Okay, how about this one? Your numerator is the gray part. How many do we have shaded in? 1. Out of how many total? 2. So we have 1/2 shaded in gray. You could also say 1/2 is shaded in white if we were focusing on the white part. Here we have 6 total pieces, so that's our denominator, and we have 3 shaded in gray. So 1/2 is equal to 3/6, and you can see that visually. They're the same, just this one is cut into smaller pieces. Imagine if this was a pan of brownies. If I gave you half of the pan, look at all that you'd have. If I gave you 1/6, it would just be this piece of the brownie pan. Ooh, now look at this one. Here we have 2 pieces. And how many are shaded in gray? 2. So the whole thing is shaded in gray. The whole thing, that means you have 1 whole. Anytime the numerator is the exact same as the denominator, the whole thing is there. For example, when we look back here, this kid got the whole thing correct, 10 out of 10. The whole thing was answered correctly. Let me prove real fast that 1/2 is equal to 3/6. Here's 1/6, 2/6, 3/6. You see how 3/6 are equal to 1/2. They're equivalent. Then we have how many gray shade in here? 3. Out of how many total? 4 pieces. How is that equivalent to this one? This time we have 8 pieces total, and we have 6 shaded in gray. Let's prove it using whatever you do the top, you do the bottom. 3 times 2 equals 6. 4 times 2 equals 8. So they're equivalent. In this section of your worksheet, they just wanted you to create an equivalent fraction, or they wanted you to complete the missing piece to make equivalent fractions. So what we're saying here is we have 4 out of 5. Let's use the whatever you do the top, you do the bottom trick. 5 times 2 equals 10. So 4 times 2 equals 8. And let me prove that 4/5 is equal to 8/10. So I want 4/5, 1/5, 2/5, 3/5, 4/5. And we're going to make that equal to 8/10. 1/10, 2/10, 3/10, 4/10. And to save some time, I'm just going to copy these. I'm going to double them. Eight-tenths. So 4/5 is equivalent to 8/10. Two fourths and 4/6. Whatever you do the top, you do the bottom. 2 times what equals 4? 2 times 2. So blank times 2 equals 6. Must be 3 times 2. So 2/3 is equal to 4/6. Here we have 1/4 is equal to 3 what? Let's do this one again with our rectangles. So we're going to have our rectangle. We're going to cut it into 4 pieces. And this time we have just one out of 4 pieces are shaded in blue. So, oops. Now, how would we make it so that we have 3 blue shaded in? Well, I could cut it going this way. Oh, yikes, that's too thick. I can cut it going this way. So now we have 3 blue shaded in. And how many total pieces do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 3 12s. And let's prove it using whatever you do the bottom, you do the top trick. So 1 times 3 equals 3. 4 times 3 equals 12. And blank over 8 is equal to 15 24ths. 8 times what equals 24, guys? 8 times 3. So 3 times what equals 15? 5/8 is equal to 15 24ths. And just to review, so let's go back to that question we had earlier. Andy, Lee, and Val each ate half of a pizza. The pizzas were the same size, but Andy ate 1 piece. Lee ate 3, and Val ate 4. How is this possible, guys? Well, it's possible because they're all equivalent fractions of a half. So just for this purpose, let's pretend it was a rectangular sized pizza. They each ate half the pizza. So there's my half of the first pizza. So let's pretend this blue, yikes, it's getting sloppy. Let's pretend this blue represents the pizza that they ate. Andy ate 1 piece. So we could say this one right here represents Andy's. Now Lee ate 3 slices. So he had the same amount, but it was cut to smaller pieces. So Andy ate 1/2 of the whole pizza. Lee also ate 1/2, but his slices were smaller, so he ate 3, 6. And lastly, Val ate 4 slices. So we could say so she ate 1, 2, 3, 4. So she also ate half the pizza. But look how her slices are smaller. She ate 4 out of the 8 slices. So to answer our question, how is it that one ate 1 piece, one ate 3, and one ate 4? And how is it they eat the same thing? Because it was smaller pieces of the whole. All right, guys. So after doing all this, I hope that you can now better be able to identify and create equivalent fractions. We'll do more of this in class. Thanks for watching and have a great day.